Reductive amination, the preparation of an amine. Chiral amines are a prevalent structural motif found in 40% of commercially available pharmaceutical products and 20% of crop protection compounds. In reductive amination, an amine is reacted with a carbonyl group to form an imine, which is subsequently reduced to form an amine with greater substitution than the original amine. In today's reaction, a primary amine will be converted to a secondary amine via reductive amination, and the secondary amine will be acylated to form our final product. We are not forming a chiral center in today's experiment because we are using an unselective reagent, sodium borohydride. In a hood, note the weight of your beaker with a boiling chip in it. Into one side of the beaker, weigh the ortho-vanillin. Leave the beaker and solids in the hood at all times. If necessary, use your stirring rod or scapula to push the vanillin to one side of the beaker. Meanwhile, accurately weigh the paratoluene on a weigh paper and add this solid to the other side of the beaker. Note any changes. After 5 minutes, use your glass stir rod to thoroughly combine the two solids by mixing and grinding the larger pieces until the mixture becomes a homogeneous dry powder. You may now remove the beaker from the hood. Determine your crude yield and load a melting point capillary with a small amount of your crude product. Recrystallize the remaining product using heptane. Load a melting point capillary with your pure product and save a small amount for H-NMR analysis. Here, we are using deuterated chloroform for our H-NMR analysis. Return to your workspace in the hood. Place your recrystallized amine in a clean 150 milliliter beaker and add a medium-sized magnetic stir bar. Add the 95% ethanol and place the beaker on a hot plate. Turn the magnetic stirrer on and partially dissolve the amine. In the hood, weigh out the sodium borohydride and add it to your beaker in small increments, over 1 to 2 minutes. After 5 minutes from the beginning of the addition of the sodium borohydride, add acetic acid to destroy the excess borohydride and neutralize the phenoxide ion. In the hood, add acetic anhydride. Heat to about 90 degrees for 10 minutes. Replace any solvent that boils away with additional ethanol. Then, with rapid stirring, but not so quickly that you splash any solution out of the beaker, slowly add cold water. Continue stirring for 3 to 5 minutes. The beaker may now be removed from the hood as needed. Place the beaker in an ice bath for 10 minutes and then isolate the solid via vacuum filtration. Recrystallize the solid from isopropanol using hot filtration if necessary. Determine your yield. Take the melting point along with the melting point of your crude and pure products from earlier. Finally, take H-NMR spectra of the two pure products. Congratulations, you've prepared your amine.